So getting to level 2.4, which covers all of the library of functions that I expect you to know, plus piecewise functions. I know people had trouble last year with piecewise functions when they were in college algebra, so hopefully we'll make them a little bit easier. So first off, we're just going to go through some of the properties of some of the basic functions that we should know what they look like. So, graph of the square root function of x. So the square root function, we limit because we don't plug in negatives. So our domain is anything greater than 0, or you can write that include 0 to infinity if we want to use interval notation. Our range is the same thing. Y is greater than 0, or we look at anything from 0 to infinity. Our x-intercepts are 0, 0. This function is neither even or odd. It's increasing always, so it's increasing from 0 to infinity, and it has no maximums or minimums. If we look at x, the cube root of x, the cube root of x looks a little more interesting. So it does go off like this, but then it also comes down like this. So our domain for our cube root of x is all reals. Our range, again, doesn't look like it, but if we went out further and further and further, our range is all reals. Our x-intercept, again, is at 0, 0. X, cube root of x, just like x cubed, is an odd function. It's always increasing, or from negative infinity to positive infinity, because we read everything like a book from left to right, and it has no maxes or mins. The third function that we should be familiar with is the absolute value function, which itself is a piecewise function, but let's just graph it for our sake. It's increasing positively, and it's increasing negatively. So absolute value, this is our v function. So the domain, we can plug anything into absolute value, so it's all reals. The range is only numbers bigger than 0, or 0 to infinity, because we only get positive numbers out. The x-intercepts, again, at 0, 0. This is an even function because it's symmetric about the y-axis. It's increasing from, so we're going to increase from 0 to infinity, and it's decreasing from negative infinity to 0. Last off, it has a minimum at 0, 0. So this might be a lot. I expect you to know these first three to start and be able to examine all the different properties. If we flip it over, we're just going to do a quick run through of all of these functions and what they look like. So a constant function, this is y equals a. And that's where whatever number we're at, we just get a constant function. The next one we get, identity function. That's y equals x. That's a line that intersects the y-axis and has a slope of 1. The square function is y equals x squared. So our squared function will be our parabola. That's an even function. Our cube function is y equals x cubed. So that's our, as often described, table function, or chair function, excuse me, tables and chairs. Looks like this. Our square root function, which we did on the front page, is kind of a half parabola, with it starting to be a restricted domain. Our cube root function, which is off this way and then down this way. Our reciprocal function, which is we're starting to get into material that might be a little more foreign to people. That is y equals 1 over x, and that is a swoosh here and a swoosh here. This reciprocal function is odd. It also has interesting thing happen at the origin where it can't be. Last two, absolute value, which we graphed on the front. Absolute value looks like a v. And our greatest integer function. So this one looks like y equals int of x. And it only gets out integer values. So this is often referred to as a step function. And the way it looks is we include 0 to 1. Then we include 1 and go to 2. And then we include 3 and we go over to 3. And we have a closed circle, then an open circle, closed circle, then an open circle, closed circle, open circle. If we wanted to go up one more, it'd be a closed circle, then an open circle. If we went reverse, if we were at -1, we would include that to -1. If we went backwards, -2, open circle. So this is our step function. It's walking up because we're only the integers up until we get to the next number. The last page, we're going to be talking about piecewise functions. So, with graphing piecewise functions, functions that are defined by more than one equation are called and with piecewise functions, we do everything in chunks. So, let's just look at an example and we can kind of see what it's talking about. The function f is defined with these three different pieces. So from -1 to 1, I look like this first part. At 1, I am equal to 2, and greater than 1, I look like x squared. Why don't we first start off with the graph of this function? Because I think it's easier to figure out what everything else is asking us if we know what this looks like. So I'm just going to start with these intervals. From -1 to 1, I'm going to graph this first line. So from -1 to +1, I'm going to plug in -1 here. -1 times 1 is 2 plus 1, so I'm at 3. 1, 2, 3. So I'm including -1. And then if I plugged in 1, I'd get -1 plus 1, which is 0. And I'm going to not include that, so it's an open circle. And if I plugged in 0, I'd also see that, let's just double check, I think that's 2, not 1. We're going to get these points. So that's my first one, and that's, just to be clear, an open circle. So at 1, x is 2. So there's my second point. If I'm past 1, I look like an x squared. So past 1, x squared, if I plug in 1, I get 1 out. If I plug in 2, I get 1, 2, 3, 4 out. So I look like this. I'm a line down here, I'm this point, and then I look like my parabola. So if I look at A, if I go, what is f of 0? F of 0 is equal to -0 plus 1, or just 1. If I look at f of 1 we know is equal to 2. And if I look at f of 2, we already found this out. 2, I plug it into the third equation, and I get 4 out. If I look at the domain, my graph only starts at -1, and I go off from there. So my domain is from including -1 and off to infinity. So this is a bracket, and then this is a parentheses. See, there's my graph, and then I can use this to find the range. The range, the lowest point I can be on the y is 0, but I'm not including it. So for d, to find the range, it's from 0 off into infinity. I can be all of these points in between, but since this is an open circle on 0, I don't include it. We're going to spend a little more time in class with these piecewise functions, getting used to them. I think they're really important. I also think it's another interesting thing that we find when we get to calculus. Hopefully this level has given you a little clearer, more understanding of what these graphs look like.